Title of this research is Rethinking the Design of Portable Classrooms. The research is divided into 3 parts: existing knowledge, research, and design application. The abstract says that the research investigates qualitative and quantitative data through a built inventory of the portable classroom typology. Findings show that 98% of portable classrooms constructed today operated for permanent use rather than temporary use. This shows insufficiencies in areas of energy consumption, environmental control systems, and space usage. The result of the research is a conceptual portable. The result of the research is 3 new prototypes of additional classroom units showing examples of transportable, demountable, and permanent structures. For part 1 of the research, I'm going to explain the background, problems, and addressing issues. The original portable structure was called Porta-Cabin. It was invented by Donald Shepard for use as an office space in construction sites. They are defined by Robert Cronenberg as portable buildings, relocatable, and also demountable. The problem with portable structures today, they're not really portable. They're commonly used as permanent structures, which operate for more than 10 to 20 years. And one reason behind that is because of cost. Today, the DOE prioritizes their funding on repair and maintenance costs and the lack of funding. In this graph, it shows examples of the orange line that represents the DOE's request of funding to the government, and then the gray line represents the actual funding that is granted to the DOE. And so this raises a lot of issues because using a portable structure, which was designed for temporary space or for temporary use, raises issues in the lack of an HVAC system, acoustics, ventilation, overall thermal comfort, and daylighting. And 3 of the addressing issues that is explained in this research is design efficiency, energy performance, and space utilization. So part 2 of this research investigates an inventory of portable classrooms around individual public high schools on Oahu, and also cataloging different portable types using qualitative and quantitative analysis. The methodology is collecting different sorts of data, more so finding the relationship between enrollment and portable structures growth in campuses. So the next few slides are going to be studies within each campus or each public high school campus. So within this example is a low population campus, IA High School. On the left, the site shows the different portable types that coordinates with the icons below. So showing green, that's where the type 1C is located on campus. Showing yellow is the type 1B. And then on the right shows student enrollment line. So you can see that in IA High School, there's an overall decrease from the year 1997 to 2019. And then the radar graph shows the comparison between the number of variety types, average fluctuation, and number of units. So this is an example of a low population school study of a highly populated school at James Campbell High School in Ewa Beach. So you can see the relationship between the growth of student enrollment and the number of portable types, and also the number of units in total. So I'm going to skim through different campuses just so you can see the relationship between student enrollment as well as the count of portable classrooms. You can find that low populated means less portable units, highly populated means more portable units, and the results summarize these findings, just finding different relationships and observations. The next set of research investigates different portable types, so digging into the detailed part of a portable classroom, finding similar characteristics, addressing issues to the design overall, and then rating the qualitative analysis of examples of portability, building envelope insulation, and passive design strategies, but also tying into the quantitative data of measuring the floor to roof surface area, the number of student seats that's possible for possible occupancy numbers, and also the window to wall ratio. So the methodology collects data between these numbers so that you can compare each portable type within one another. And this is an example of the data collected for type 1, which is a single 12-foot by 40-foot classroom. You can see with this data how portable type 1 compares to the average portable type, and then on the right shows the overall dimensions and the physical characteristics of type 1. So I'm just going to zoom through these images in these slides so you can see a comparison between each portable type study. And then the results explains the strengths and the weaknesses, and then also the overall findings of what an average portable type would be. On average, they're very low in roof surface area and low in floor area, so it's not very efficient of space usage. And in terms of qualitative analysis, they're not very portable, not very flexible, but they're averaged out in ventilation, daylighting, and insulation. So that brings into the design application of creating 3 new prototypes, and we're introducing a new term called additional classroom unit. To explore 3 different prototypes, the research looks at 3 different scenarios where type 1 shows a temporary portable structure, type 2 shows a short-term demountable, and type 3 shows a permanent structure. The design goal for type 1 is to be solely temporary and flexible use, but also designing for transportation between different campuses. These are the project brief, adding restrictions to what the interior needs are, exterior needs, structural, and site needs. Concept is to create a very deployable structure that can fold in for transportable, but also fold out for occupant for functional use. And in order for that to be possible, the exterior finishes have to be demountable so that the structure can fold as a whole, but also the demountable parts can be panelized so they can be stored inside the structure while it's being transported. So this is a more detailed step of the folding diagrams, which is divided into 3 steps, where you're folding the walls in first in step 1, and in step 2 you're folding the roof, and in step 3 you're folding the floor. And to stick with the concept, applying flat pack furniture that can easily be assembled but also disassembled for storage use. Each furniture can fit on a single 4x8 foot plywood sheet, and this is a diagram of how those components can be stacked and stored inside the overall structure while it's being transported. The space will be utilized as an open space, spacing out the student desks generously so that there's circulation around. Section views of the building, elevation views of the structure, and then perspective views of the overall interior view and the exterior view. The next ACU type is a short-term demountable structure, and goal 1 is to design for a demountable structure for short-term use, which could last about 2 to 7 years, but also designing for modular parts and rapid constructability. And so these are the needs that are laid out for the overall structure itself. Some of the key things is constructability, but also modularity, and thinking about the logistics of design a system that can create a whole building system as a whole. So that concept came from designing the smaller components first, so making everything all modular in 4x8 components, and thinking about the overall system as a kit of parts, but also thinking about flexibility and different choices. So opportunities where you can apply windows, doors, and screens, but also having a base wall too as well. And this is an example of how the building is going to be structured as a whole, starting from the structural beams to the floor system to the wall and then to the roof, and then stacking the components so that you can easily store it into a 8-foot container or 8 feet wide container. And this is the overall feel of, or the overall space of the building. You can see that the floor system is all modularized in 4x8 components. At the south, you have the teaching wall where there's no fenestrations, but along the east, north, and west walls, you have operable windows, but also on the west and east ends, you have opportunities for shading, so you don't have the direct sunlight coming into the classroom. It's the roof plan of type 2, elevation, and then the right and left elevations and the overall section of the building, and renderings of type 2. So just getting a feel of how the space will be when you're inside, and then with the flat pack furniture around spaces, and then showing an example of how the entry will be for students to be walking along the ramp, and then having an entry door come in. ACU Type 3 is designed for permanent long-term use, so 7+ years, and also designed for innovative and rapid constructability. Some of the needs are applying a permanent foundation, and also designing something that can easily be built so that you can install buildings like during the summer in a 2-month span, but also thinking about durability and long-term use. So similar to Type 2, but more improvements of thinking about flexibility. So applying opportunities where you can use these swivel panels for writing surfaces, so you can create a collaborative space between indoor and outdoor spaces, but also creating more spaces outside where students can gather and wait for classes to begin or wait for classes to end, but having that overall feel of flexibility. So using movable furniture for students to create their own classroom layout. And then the roof is designed so that it's a butterfly roof, so the slope goes inwards to collect rainwater, and then a roof to generate more energy. So these are the elevations of the building, showing the butterfly roof and different textures of the exterior. And in the section you can see that we have a clear story window to allow daylight to come in, but also having hot air to come out. So the interior view showing the movable furniture, and then the exterior view showing the overall feel and atmosphere of the space. So you can see over here the swivel panels, which can be applied as a writable surface. And so in conclusion, comparing these types to the average portable types, you can see how ACU type compares to ACU type 1 compares to average portable type, showing improvements in areas like ventilation, daylighting, as well as mobility and portability. And then ACU type 2 in comparison with the average portable type, and ACU type 3 in comparison to the average portable type. So in conclusion, if I was to apply further studies, I would definitely look more into the, especially for type 1, the structural or folding mechanism, try to get it value engineered to see if it's a feasible concept, but also running simulations in charting the daylighting numbers and also ventilation strategies. Type 2, bringing the overall concept into a physical mock-up to see how each component of parts would be constructed together. And then type 3, having similar iterations of physical mock-ups of construction, but overall applying user inputs for design, and having that chance to get to interview students and teachers in the overall user experience, and also applying a cost analysis to see what is the long-term benefits of creating passive design strategies or more effective systems, mechanical systems. How is that going to benefit a school that would apply these ACU types into their campus? And also getting feedback from community design charrettes, just to hear from the public, and also site opportunities, since these units were designed as a one-size-fits-all, and every site on Hawaii especially is different in climate, so figuring out a way to adapt these base structures into a more fitting site environment would further improve the research. So thank you.